Hi, in this video we'll learn about electronegativity, polarity, that is polar and non-polar molecules, and exam style questions. It is necessary to learn about electronegativity and polarity before we start learning about intermolecular forces. So let's begin by learning the definition of electronegativity to learn what is actually electronegativity. Electronegativity is the ability of a covalently bonded atom to attract the bond pair of electrons towards itself. Now let's understand what do we mean by this definition. It says that it's a covalently bonded atom. So let's understand by taking it with an example. Say atom A is covalently bonded to atom B. Now as we know that there is a shared pair of electron with this bond. So when we say it's a shared pair, one of the electron is shared by atom B and the other electron is shared by atom A. Now when we say an atom is electronegative, that shows that this pair of electrons, in fact this bonding pair of electrons, are attracted to one of the atom itself. Say B is more electronegative, then this bonding pair is going to get attracted towards B. So you can represent this molecule again with such an example where both the electrons from B as well as A has moved towards the atom B. So you can see here that both the bond pair of electrons, as we have written here in the definition, it's a covalently bonded atom attracts the bond pair of electrons towards itself. So we can say that B is more electronegative because it has attracted this electron pair towards itself. So you can also say that the charge between the atom A and B is unequally distributed. So you can present this molecule again this way, where both the electrons are towards only one atom. So here we can call B as a more electronegative atom compared to A. Now we also need to understand that all the atoms are not equally electronegative. That is, each and every element has its own electronegativity measurement. Electronegativity is measured on a Pauling scale because it was invented by the chemist Linus Pauling. So Pauling scale gives you the difference in the electronegativity of different elements with different scale. Now let's study this periodic table to understand the difference in the electronegativity of various elements. But before that, we need to understand that electronegativity is also related to electron affinity because it has something to do with attracting the electrons. So let's consider the elements of group 1, say lithium, sodium, potassium. Now these group 1 elements, we know that they have a tendency of losing electron. But we also know that as we go down the group, the size of the atom increases. That is, the outer electron, which has to be attracted to the nucleus, goes farther from the nucleus. So as the outer electron moves farther from the nucleus, the attraction between the electron decreases. That's the reason that as the size of the atom increases, the attraction decreases. So in that case, we can say that down the group, as size of the atom increases, the electronegativity should decrease. But it is difficult to understand in case of the groups which have metals. So let's consider group 7, which has non-metals and which are more electron affinitive so that it can attract the electrons more easily. So let's consider group 7 to understand the change in the electronegativity down the group 7. Say suppose we are considering fluorine. Fluorine, as we know, is in period 2, so have 2 shells. Chlorine have 3 shells because it is in 3rd period. Now, if we want to attract an electron on towards the atom, it has to be attracted on the outer shell. So as we can see that in fluorine, the outer shell is only 2 shells away from the nucleus. But in chlorine, if an electron has to be attracted on the outer shell, it is 3 shells away from the nucleus. So we can understand that it is difficult to attract an electron on the outer shell of a chlorine which is farther from the nucleus. The same case we can consider for the bromine also, where the bromine nucleus, that is bromine atom, have 4 shells. So when we are attracting an electron on the outer shell, we know that the electron to be attracted is much farther from the nucleus. So it is even difficult compared to chlorine to attract the electron on the outer shell. So from this example, we can understand that as we go down the group, the electronegativity should decrease. Now let's understand the difference in the electronegativity across a period. Consider period 3. So sodium, magnesium, aluminium, silicon, we know that the nuclear number increases as we go along the period from left to right. Now sodium have 11 protons, magnesium have 12 protons, aluminium have 13 protons, that is the nuclear charge increases from left to right along a period. Now as we know that electrons are added in the same shell, that is the 3rd shell, as it is in period 3. So distance of the outer shell from the nucleus is almost same. So that is the reason that distance doesn't matter. But as the proton number, that is the nuclear charge, increases from left to right, that is, it's easy to gain an electron on an outer shell of the atom because the attraction between the outer shell electron and the nucleus increases. So from this, we can conclude that electronegativity increases across a period, that is from left to right, and it increases up the group, that is, as we have considered group 7, the element, the atom on the top of the group will have the highest electronegativity. So as we had considered the group 7, fluorine, chlorine and bromine, electronegativity increases up the group, that is, fluorine will have the highest electronegativity in group 7. So we can conclude that across a period, electronegativity increases as the proton number, that is the nuclear charge, increases, and the charge of the nucleus as it increases, it attracts the bonding pair of electrons toward itself more strongly. Suppose if we consider period 2, that is lithium to fluorine, we can say that the electronegativity increases from left to right, that is from lithium to fluorine. So in this period, the fluorine will have the highest electronegativity and lithium will have the lowest electronegativity. And also electronegativity increases up a group, that is, as the number of shells increases down the group, the outer electron gets further away from the nucleus. That is the reason that the attraction between the nucleus and the outer bonding pair of electrons decreases. That is, you can say that it is difficult to attract an electron on the outer shell which is much farther from the nucleus. That is the reason that fluorine is highest electronegative and bromine or astatine or iodine are less electronegative. So fluorine is more electronegative in group 7. Now this is a table showing electronegativity values on a Pauling scale. Now here in this table you can see various values written below each and every element. Now this is the value of electronegativity of this particular element. Now let's understand what is polarity. Polarity is directly related to electronegativity, and we need to find out whether a bond, a covalent bond or a molecule is polar or not. Let's consider an example, say HCl molecule. Now in an HCl molecule, if we look at an electronegative Pauling scale, hydrogen has an electronegativity of 2.20 and chlorine has an electronegativity of 3.16. From this, we can conclude that chlorine is more electronegative. So we can understand that the bonding electron pair is attracted towards chlorine more. So you can say that chlorine is more electronegative because it has attracted the bonding pair of electrons towards itself. Because chlorine has more attraction for the electrons towards itself compared to hydrogen. So on a molecule, if we want to present a polarity, we need to draw an arrow pointing towards more electronegative atom with a line at the end showing that hydrogen is electropositive. And we can also present it by drawing delta positive and delta negative on a molecule to present that chlorine is more electronegative compared to hydrogen. So you can say that such a molecule where there is a polarity, you can say that a molecule has a permanent dipole on its bond. That is, you can also say that this bond is polar. And if a molecule have only 2 atoms like this, you can also say that the molecule is polar. Now let's consider an example of sodium chloride, where sodium is a metal atom and chlorine is a non-metal atom. Sodium has a polarity of 0.9 and chlorine has a polarity of 3.16. Now you can see that the difference in the polarity is very high. So in this case, rather than chlorine attracting a bonding pair of electron towards itself, it actually takes away the whole electron, leaving sodium as fully positive and chlorine gets fully negative. That's the reason that electrons are not shared between the sodium chloride molecule, but they are transferred from sodium to chlorine, that is a less positive, less electronegative atom to more electronegative atom. And that's the reason that sodium chloride is not a covalent molecule, but it's an ionic molecule. From this, we can conclude that when the electronegativity values of the 2 atoms forming a covalent bond are not the same, that is, they are not identical, the pair of electrons is unequally shared between the 2 atoms and the bond becomes polar. That is, we have already considered the example of hydrogen chloride molecule, HCl molecule here, where the bond is polar because chlorine is more electronegative compared to hydrogen. Now suppose if the 2 atoms forming a covalent bond are identical, then the bond is not going to be a polar, that is, the bond is non-polar. Take an example of an hydrogen molecule. Now as we can see that as both the atoms are identical, both the atoms are same. So both of the atoms have the same electronegativity value, and that is the reason that the charge between these two atoms are equally shared, and so the molecule turns out to be non-polar. So any such molecule, say chlorine molecule, hydrogen fluorine molecule, or bromine molecule, maybe an oxygen molecule, all the atoms forming the molecule are identical. That is the reason that both the electrons which are shared between these two atoms are equally shared between the two atoms. That is, the charge is not unequally distributed. It is equally shared between the two atoms, and such molecules are non-polar molecules. Now, if we don't consider a molecule and we are just considering a atom, a bond, say OH bond. Now let's understand whether this bond is going to be polar or not by again looking at the electronegativity values. Oxygen, you can see that here is having a value of 3.44 and hydrogen as 2.20. So we can say that oxygen is more electronegative compared to hydrogen. So we can show the polarity with such a sign, and we know that this bond is polar. Although this is not a molecule, this is a bond, but this bond is polar with oxygen as electronegative and hydrogen as electropositive atoms. Now let's consider another example of carbon and hydrogen bond. Now we know that hydrogen have an electronegativity of 2.2 and carbon have an electronegativity of 2.55. Now we can see that the electronegativity difference between carbon and hydrogen is very less. Because of this reason, this bond, that is the carbon-hydrogen bond, is considered to be non-polar. But on the other hand, the OH bond is considered to be polar. From this, we can conclude that there should be minimum some difference in the electronegativity values of the two atoms to make that bond polar. So let's understand what is that difference. The difference in the electronegativity, if is less than 0.5 between the two atoms, then that bond or that molecule turns out to be non-polar, and if the electronegativity difference is greater than 0.5, then that bond or the molecule is considered to be polar. So here we can understand with this example of carbon and hydrogen bond, we know that the difference here is only 0.35, which is lesser than 0.5. That's the reason that the carbon-hydrogen bond is non-polar. From these examples, we understood that some of the molecules are non-polar and some are polar. Now we have already understood that some bonds are polar and non-polar, but let's understand that with the help of some molecules. Now let's consider an example of carbon dioxide molecule. Now we know that carbon dioxide molecule is a linear molecule. We can see that in the bond, carbon-oxygen bond, only one bond, oxygen is more electronegative and carbon is an electropositive atom. So this bond, CO bond, is a polar bond. But although this bond is polar with an electronegative charge on oxygen and electropositive charge on carbon, this molecule is non-polar. The reason is that the oxygen on both sides of carbon cancel each other's polarity. Because this molecule is symmetrical and oxygen are the two same identical atoms on the both sides of carbon, it cancels each other's polarity, or you can say electronegativity, and that's the reason that carbon dioxide molecule is non-polar, although the carbon-oxygen bond is polar. Similarly, let's consider another example of carbon tetrachloride, that is carbon with 4 chlorine around it in a tetrahedral shape. Now we can again understand here that carbon is an electropositive atom and all chlorine are electronegative atoms. But they are arranged around the center carbon in such a way that it cancels each other's polarity, and that is the reason that carbon tetrachloride, that is CCl4, is non-polar. This is because of the symmetry in the shape of its molecule. So we can conclude that in a symmetric molecule, the atoms cancel each other's polarity. That's the reason that the molecule is non-polar. And the shapes which give the symmetry to the molecules are linear, triangular, planar and tetrahedral shape. These three shapes of a molecules gives them symmetry, and that's the reason that the molecules having these shapes turns out to be non-polar. Similarly, we can say that in non-symmetric molecules, there is a slight difference in the charge of the molecule due to its shape. And so, there is an overall dipole on the molecule, and so the molecule turns out to be polar. Let's consider an example again. Say there is a water molecule with oxygen and hydrogen. As we know, its shape is a bend shape. And we also know that hydrogen is an electropositive atom and oxygen is an electronegative atom. In a carbon dioxide molecule, we had seen that it also has 2 oxygen atoms around carbon. But due to its linear shape, the electronegativity of oxygen was cancelling each other. But here we can see that the shape is a bent shape, and so hydrogen cannot cancel each other's electronegativity. That's the reason that water molecule is a polar molecule because of an non-symmetry in its shape. And there is an overall dipole on such molecules. Let's consider another example of a chloromethane, where there is 1 chlorine atom on this methane molecule. Now we know that chlorine is electronegative more than hydrogen. Hydrogen is an electropositive atom. Now in this, due to its shape and a non-symmetry in the molecule, we can conclude that such a molecule is a polar molecule with this end as electropositive, and the molecule with the chlorine atom is electronegative. So such a molecule is again polar due to its non-symmetry and its shape. Now let's discuss some exam style questions. Question 1 says, ammonia is a polar molecule, whereas methane is non-polar. So explain why ammonia is polar but methane is non-polar. Before we find out the answer, let's discuss the shape of the ammonia. Ammonia have nitrogen with hydrogen in a pyramidal shape and with a lone pair. But in methane, we can see that it's a tetrahedral shape with hydrogen all around. So because of the shape of the ammonia, we can see that ammonia is not symmetric and the charge of the ammonia and hydrogen is unequally distributed. So we can say that ammonia has a pyramidal shape and it is not symmetrical, and so the dipoles don't cancel each other. But methane has tetrahedral shape which gives symmetry to the molecule, and so the dipoles cancel each other, which makes methane non-polar, while ammonia, because of its symmetrical shape, the ammonia is a polar molecule. The second part of the same question says, Explain using ammonia as an example the meaning of the term bond polarity. Now we have already seen the shape of the ammonia, which is trigonal pyramidal shape with a lone pair on the nitrogen. So we can say that ammonia molecule has the two atoms forming the bonds which are unidentical. That is, one of the atom is nitrogen and the other atom is hydrogen. So both of it are unidentical. That is, they are not the same atoms. So the more electronegative atom, that is nitrogen, attracts the bonding pair of electron towards itself. This makes the bonds polar. That's the definition of bond polarity. That is, a bond will be polar when the two atoms forming the bonds, that is nitrogen and hydrogen in our case, both of it are different and one of the atom is electronegative in our case, which is nitrogen. This makes the bond polar. The next question is question 2. Explain why HCl molecule is polar. Now we know that HCl is a molecule with a covalent bond between hydrogen and chlorine, and we know that chlorine is more electronegative than hydrogen. That is, the bond polarity can be presented with an arrow as shown. So we can say that in HCl molecule the chlorine is more electronegative than hydrogen, and so chlorine has a greater attraction for the bonding electrons. Bonding electron means the electron which is forming a bond here between hydrogen and chlorine. This makes the HCl molecule polar. The next question. Which of the following molecule is polar? We have four options here. One of it is carbon dioxide, ammonia, boron fluoride molecule and carbon tetrachloride. Now before we get the answer, let's discuss the shapes of all these four molecules. Now we know that carbon dioxide is a linear molecule where carbon is at the center and it has two oxygen on the both sides which are equally electronegative. So because of that, the polarity of oxygen cancel each other. But in ammonia molecule, as we have discussed in the earlier question also, have a shape of trigonal pyramidal, where we can say that because of its shape, the molecule is not symmetric and the polarity doesn't cancel each other. So ammonia is of course polar, but let's discuss the shape of the boron fluoride molecule also before we get the correct answer. Boron fluoride, as we know, is in group 3. So when it forms 3 bonds with the fluorine molecule, it doesn't have a lone pair on the fluorine. Sorry, its shape will be trigonal planar, so it should be a proper trigonal planar as drawn here. So as boron is not left with any lone pair, so because of that it has got a trigonal planar shape which is symmetric and it has the dipoles cancelled each others by the fluorine. And about carbon tetrachloride, again we know carbon tetrachloride is going to form a tetrahedral shape. And again the chlorine are equally electronegative on all sides, cancelling each other's polarity. So because of that, the only option, correct option left with us is ammonia, which is polar molecule because of its non-symmetrical shape. So in this video, you have learnt about electronegativity, polarity, polar and non-polar molecules and some exam style questions. This is the base for studying the intermolecular forces. So in our next video, we'll be learning about intermolecular forces. So keep watching.